Hi guys, course flow is, as the name implies, to bring you up to speed about where we are at this stage and how we can proceed in a particular section. So right now we have just started the implementation and we have divided the self-driving process into two stages, detection and control. The first feature that we intend to develop is known as lane follow, and for this we require the detection of the lane lines. This process starts by the segmentation of lane lines on the basis of color. Then we use estimation to fill in the gaps. And finally, after some cleaning processes, we can finally proceed to the control stage. Hello people, to provide the ability of lane follow, we need to think about what it is that we as humans do when driving, what are the traffic rules, etc. The most basic driving tip that we are given is to stay within the lines and not drift either way. We require somewhat same concept, but in a more explicit manner. For example, if we could look at what our car was seeing from its size, let's say this frame here. What we want our AI car to do is to understand where the lane boundaries are. So the first major step in lane detection is to segment complete lane lines. Once we have the lane lines, we need to provide our AI car with some mechanism to relate its position with those lane lines. This data will be our final output. In coding terms, we have this frame as an input, and we require somewhat following output. So let's go through this step by step. Hi guys, we just went through testing edge as a probable segmentation feature for lane detection, but we found out that edge, although being a very useful feature, still suffers from being a complete segmentation tool, and we would like to focus on another feature, that is of the color. But before that, I would like to mention a few points of theory. Generally, images are in RGB color space. What this means is that images have three channels in them, the first one being the red channel, the second one being the green channel, and the third one being the blue channel. Combining all these three channels is how you get the multicolor image you see today. So if you want to segment any object of a particular color based on color, you can do that by simply selecting that we want all the regions in the image that are within that color range. So how can we fit this color segmentation idea in our case? As you can see in the image shown below, the lane lines or outer lane lines are of a particular yellow color, and the middle patch lines are of white color. And this is not distinct in only our case. This is not specific to our case. This is like this all along the world. All the lane lines have a distinct color, so color can be a very useful feature for segmentation of lane lines. Once we have identified the color being a very useful feature for segmentation for lane lines, now the problem exists on how to use it. Can we use color segmentation inside the RGB color space? We cannot. The reason being that RGB not only carries the color information inside it, it also carries the lightness and the amount of color inside it too. So if you want to segment out a particular color, you will struggle because that particular object will have different lighting based on the amount the light source placement, and its amount of color would also vary. So you will get a patch result and not a complete result. So this is not recommended. Instead, what we would recommend is to go to another or convert to another color space that has the color information separated out from all the other information placed there. What we would like to use as a color space for color segmentation would be the HSL color space, which simply means hue, saturation, and value. Hue represents the thing that we need the most for color segmentation, the color of the image, and saturation means the amount of color, and the lightness means the amount of light. We are only interested in the hue because hue represents the color information. So if you want to segment a particular color object, we can do that by saying that we only want the objects that have that particular hue in them. So this is how you get that particular color object segmented based on color. On the right hand side, you can see that HSL color mapping is shown mapped to a cylinder. Now this is for understanding only. On the circumference of the cylinder, hue is shown changing along the circumference. And on the going from bottom to top of the cylinder, you can see the lightness is changing from darker to white light on the top of the cylinder. And going from inwards to outwards, you can see the saturation or the amount of color is increasing drastically. So if you want to segment based on color, you can do that by saying that I want the hue of that particular color, and all the lightness or all the saturation can be used, and only that color should be segmented out. So this is a very useful tool and the very useful color space for color segmentation. Now moving to the code flow part. So we now have an idea of why color segmentation seems to be a decent approach. But in order to code it, we need to understand the segmentation based on color will not give us the desired result. Instead, what we will get as an output is some noise along with some incomplete segmentation. This is because of using only a single feature, that is color. To overcome these issues, we require some morphology operations along with extraction of the edges of lane lines. This means that our final output will be the edges of those lane lines.